Hello everyone, welcome to our channel Masters in Chemistry. Today I would like to discuss few topics in electrochemistry. Friends, when I would like to discuss about electrochemistry is a part of chemistry, right? The word electrochemistry means that the chemical energy which is obtained by electrochemical reaction. Let me ask a question, right? What is meant by electrochemical reaction? Electrochemical reactions, the basic reaction with the oxidation reaction, reduction reaction. Now we will see step by step. The first basic thing we are identifying in the electrochemistry is galvanic cell. I'm repeating. Now we are discussing about galvanic cell. Galvanic cell is the first basics of electrochemistry. Now, in your examination, the questions are asking like this: construction, working of electrochemical cell. Now, you can have a diagram here. Let me explain what is known to be the galvanic cell. Now, when we are discussing about the galvanic cell is made up of two electrodes, and here we can have the first electrode, and here we can have the second electrode. The first electrode I'm saying as zinc rod. I'm repeating. It is known to be the zinc rod. The second one is known to be the copper rod. Now we should place zinc rod in a solution of zinc sulfate. We should place the copper rod in the cupric sulfate solution. You can have two beakers here. Now this is the first beaker. It is known to be the second beaker. Or I'm taking. It is known to be that the first solution medium, and it is known to be that the second solution medium. The first solution medium, zinc rod is taken in the zinc sulfate. In the second solution medium, the copper rod is taken in the cupric sulfate solution. Now, I would like to connect the two electrodes, zinc rod and the copper rod, with an external electrical circuit, which is known to be the voltmeter. Okay. Then, zinc and the copper rod both should be connected to the voltmeter. Then what happens? You see here, zinc rod is taken in the zinc sulfate and copper rod is taken in the copper sulfate. Now, zinc rod is placed on the left hand side and copper rod is placed on the right hand side. Now, zinc rod in the zinc sulfate, zinc rod is oxidized. Now, this point is very, very important. Now, when we take the chemical reaction in the galvanic cell, here, zinc rod is oxidized. I can write these two electrons. Zn gives rise to Zn2 plus 2 electrons. Now, what is known to be the loss of electron? Loss of electrons is known to be oxidation reaction. Next one, what happens here? Copper gains electrons, and the gain of electrons is known to be reduction reaction. Let me give you the clarity. When you are discussing about galvanic cell, in the galvanic cell, zinc rod is taken in the zinc sulfate, copper rod is taken in the cupric sulfate. Now here, zinc donating electrons, zinc is known to be in the solid state. Now this zinc donating electron, and it is converting into Zn2 plus. Now repeat, Zn gives rise to Zn2 plus 2 electrons. When the zinc rod is taken in the zinc sulfate, zinc undergo oxidation reaction, and this reaction what we are saying as anodic reaction. Anodic reaction is always oxidation. Now, these two electrons are travel along with the medium, and this medium I'm saying as salt bridge. I'm repeating. The two electrons travels from zinc sulfate to cupric sulfate. The two electrons travel from zinc sulfate solution to the cupric sulfate solution. When these two electrons travel from zinc sulfate to cupric sulfate solution, then what happens? Now, zinc donating the two electrons, loss of electrons is going to be oxidation, and these two electrons gained by the cupric sulfate containing copper, gain of electrons is going to be reduction reaction. So I'm saying as zinc is known to be donor and copper is known to be acceptor. I'm repeating. Zinc sulfate is known to be donor, copper in the copper sulfate is known to be acceptor. We can see the two types of reaction. The first chemical reaction here is oxidation, and the second chemical reaction is going to be reduction. Let me see the part of galvanic cell. Galvanic cell is made up of number one, two electrons. The first electrode is a zinc rod. The second electrode is copper rod. Then zinc rod is placed in the zinc sulfate and copper rod is placed in the copper sulfate. Now these two electrodes are connected with an external electrical circuit. I'm repeating. The two electrodes are connected with an external electrical circuit. It is known to be voltmeter. Anode and the cathode, zinc to the zinc sulfate and copper in the copper sulfate, both are connected to voltmeter. Now, this voltmeter is known to be an external applied electric field. Now, the two solutions are connected along with the medium, and that medium, what we are saying is salt bridge. Salt bridge is made up of KCl and as well as agar gel. Then what happened? During the electrolysis condition, during the galvanic cell reaction condition, anodic reaction is oxidation and cathodic reaction is reduction. Oxidation means that loss of electrons, reduction means that gain of electrons. Zinc donating the two electrons, and these two electrons travels along with the salt bridge. That two electrons travels along with the salt bridge, which is taken in the cupric sulfate. Copper sulfate absorbing the two electrons. Loss of electrons is known to be oxidation. Gain of electrons is known to be reduction. Resultant, the flow of the electricity takes place. Let me ask you a question. By the galvanic cell reaction, the flow of the current takes place. What is the flow of the current? When we are discussing about the flow of the current, the free flow of electrons from one place to another place is known to be the current. I'm repeating. The free flow of electrons takes place here, zinc sulfate to copper sulfate. Now the free flow of electrons takes place from zinc sulfate to copper sulfate is nothing but flow of the current. The amount of the electricity produced when zinc is taken in the zinc sulfate and copper rod is placed in the copper sulfate, which is calculated in the voltmeter. I'm repeating. The amount of electricity produced when the flow of the current takes place from zinc to copper. The flow of the current takes place from zinc to the copper, which is calculated in the voltmeter. That might be 1 volt, 2 volt, that might be X and Y, right? Now, the voltmeter calculates amount of electricity produced during the galvanic cell reaction, amount of electricity which is identified based on the concentration of zinc sulfate solution and the concentration of copper sulfate solution and oxidation reaction and as well as reduction reaction. You will see the continuation here. When you're discussing about galvanic cell or the voltaic cell working, galvanic cell is explained based on the conversion of chemical energy to electrical energy. This point is very, very important. Whenever we're discussing about the galvanic cell which converts the chemical energy to electrical energy. Number. It generally consists of two metal connected electrodes. Just now we have discussed. One should be zinc rod and there should be copper rod. And both rods are connected along with the medium, and that medium what we are saying is salt bridge. The medium is known to be the salt bridge. Next one. A common electrochemical or the voltaic cell is known to be Daniell cell. Now this a common electrochemical cell when we are discussing about is known to be Galvanic cell. Now when we are discussing about galvanic cell, it's containing two half cells. I'm repeating. The first half cell is zinc rod is taken in the zinc sulfate. The second half rod is copper rod is taken in the cupric sulfate solution. I'm repeating. The first half cell zinc rod is taken in the zinc sulfate. The second half cell copper rod is taken in the copper sulfate solution. Now the solution of zinc sulfate is 1 molar concentration. The solution of copper sulfate is also 1 molar concentration. I'm repeating. The solution of zinc sulfate is 1 molar concentration. The solution of copper in the copper sulfate is also 1 molar concentration. Then what happens? Because of electrochemical reaction, zinc rod is oxidized, copper rod is reduced, and because of the redox reaction, oxidation reaction followed by reduction reaction. Zinc sulfate is oxidation reaction. Copper sulfate is going to be reduction reaction. Any chemical reaction which is the combination of oxidation plus reduction, the It is known to be redox reaction. Because of redox reaction, electrochemical energy is produced. Now we will see the chemical reactions here. Okay, zinc which donates electron. Okay, anodic reaction, oxidation reaction, zinc which donates electron. Then cathodic reaction is reduction reaction, copper which gains electrons. I'm repeating. Zinc which donates electron and copper which gains electrons. Loss of electrons is oxidation reaction and the gain of electrons is reduction reaction. Now oxidation reaction which is indicated by the symbol negative, and this point is very important. E is equals to minus of 0.77 volt. Okay. Now this negative symbol indicating the oxidation reaction. Reduction reaction indicated by the positive symbol. Reduction reaction indicated by the positive symbol. Now, electrochemical reaction. During the electrochemical reaction, the copper value is 0.37. Mostly in some of the textbooks, it is given like 0.34. It is 0.34 is accurate. Okay. Now, zinc is oxidized. The value is 0.76. Copper is reduced. The value is plus 0.34. Now we will see the net reaction. Zinc is combined with the copper. Zn is converted to give Zn2 plus, and copper is converted to give Cu. Zn gives rise to Zn2 plus, Cu2 plus gives rise to Cu. Now what is oxidation reaction? Oxidation number increases. Oxidation. What is reduction reaction? Oxidation number decreases. Reduction. When the oxidation number increases, it is going to be oxidation. When the oxidation number decreases, it is going to be reduction. Simply. Here oxidation state value is equals to 0. And here the oxidation state value is equals to 2. Oxidation state number increases, oxidation. Oxidation state number decreases, it is going to be reduction. Now, we will see the net reaction in the galvanic cell. In the galvanic cell reaction, zinc metal rod is oxidized, copper metal rod is reduced. Zinc metal rod and the zinc sulfate is oxidized, copper and the cupric sulfate is reduced. Now we'll see the following observations. The flow of the current takes place from zinc electrode to copper electrode. So zinc is going to be anode, copper is going to be cathode. The flow of the current takes place to anode to cathode. Zinc to copper. Number two. Zinc rod loses electrons when the copper rod gains electrons. Zinc rod anode, copper rod is going to be cathode. Loss of electrons is oxidation and the gain of electrons is reduction. Next, the concentration of zinc sulfate increases when the concentration of copper sulfate decreases. So we are taking equimolar concentration, right? If you are increasing zinc sulfate concentration, then the concentration of copper sulfate concentration decreases. Solutions in the both compartment remains electrically neutral. Zinc sulfate is a salt, copper sulfate is not to be salt. I'm repeating. Solutions in the both compartment. Zinc sulfate, the first compartment, copper sulfate, the second compartment. Zinc sulfate is a neutral, and the copper sulfate is also known to be neutral. Then how we are representing galvanic cell, and this point is very, very important. Galvanic cell can be represented like this: zinc slash Zn2 plus oxidation, 1 molar concentration, Cu2 plus slash Cu, 1 molar concentration. Oxidation, salt bridge notation, reduction. I'm repeating. Zn by Zn2 plus 1 molar concentration, Cu2 plus Cu, 1 molar concentration, left hand side oxidation reaction, right hand side reduction reaction. Friends, now this is the basic concept of electrochemistry, galvanic cell reaction, electrochemical cell reaction, where the chemical energy is converted into electrochemical energy. The continuation we will see in our next class. Thank you.